Okay, here's a problem that came across my desk. This is from a commenter who wrote 3 to the 0 power minus 1. So we're going to simplify this. First, any number to the 0 power is 1. And so this simplifies to 1 minus 1, which is 0. So I'll circle my 0, and it looks like a nice donut or a car tire or something like that. And that is the fully simplified form. Let's go ahead and do another one for the rules of exponents and simplifying expressions that contain exponents. Because I do want to keep these videos short, but I think we have time to do another one here. So let's talk about another property here. We've got negative 3 times negative 6 inside of parentheses here, and then we've got an exponent on those parentheses. Now, there's more than one way that I can do this. But I do want to illustrate the property of the power that will be helpful in other contexts. One thing I could do, and technically like what I should do, is any operation inside of parentheses first. So negative 3 times negative 6 would be positive 18. So this entire parenthetical expression reduces or simplifies to just 18. And now I've got to the negative third power. Let's talk about what negative exponents represent. They represent the reciprocal of the same base with the positive exponent. So this is 18 to the negative third power over 1. And if I flip that fraction over, or reciprocal or multiplicative inverse, it becomes 1 over 18 to the third power. I could simplify 18 to the third power by performing the multiplication 18 times 18 times 18, but that's not really the point of the example. The point of the example is to illustrate the property of exponents, and I actually kind of prefer to leave it in this form unless I'm told to fully simplify it. Then I'll do the multiplication off to the side. But 1 over 18 cubed is about as good as it gets as far as I'm concerned. Now let's talk about the other way to do this using another property of exponents. And that is I can distribute. I'm using the word distribute loosely here, but I can distribute the exponent that's outside of the parentheses to each factor that is inside the parentheses. So this becomes negative 3 to the negative third power times negative 6 to the negative third power. And then again, using that same property I used over here of the negative exponents representing reciprocals, this becomes negative 1/3 to the third power. I can put that third power in a couple places, so I'll just kind of put it there. And I've got my times, and I've got my negative 1/6 to the third power. Again, I can also put that third power there. I'm just kind of showing some options here. Yeah, so then I can multiply these together. It probably would be better for the illustration of the next step. I'm going to go ahead and move that. Pick a marker here. I'm going to move that third power there. Technically, it goes to the 1 also, but 1 to the third power is still just 1. So I've got 1 over 3 to the third times negative 1 over 6 to the third. And then I could multiply this all out, and you would end up getting the same thing, because, 3 3s and 3 6s all multiplied together would be the same as 3 18s all multiplied together. Hello. Make sure it shows on camera. So just some different options there. Yeah, and there are probably a few other things we could do as well. So there are 6 rules of exponents. You'll have books that say 8 or different numbers of them, but there are basically 6. It just kind of depends on how you count them. There's some room for argument there. Anyway, while I'm rambling, the point is you can apply the rules of exponents in any order you want. It's not really strict to PEMDAS or anything like that, because the exponents are one line of PEMDAS, the E, and so you can do all the different exponential tricks in whatever order floats your boat. And if we finished simplifying this, we would end up with the same answer anyway. A negative times a negative makes a positive, so I may as well mark that. All right, if you have a math problem that you would like me to demonstrate, put it in the comments, and I will. Hope that helps.